Hello and very welcome to this next week. And previous week we have studied digital electronics. Today, this week we will study analog electronics and op amps. Okay, so op amp is often very frightening, very scaring to many students. It was also true to some extent to me, but I think if we study it carefully, this is one of the easiest easiest element in electrical circuits. Okay, what is an op amp? Op amp is nothing but an electrical equipment which has two inputs and one output. Okay, so we possible that we draw it with a triangle. Okay, and it has two inputs. We denote them as plus and minus, and it has one output. Okay, so these are inputs and this is the output. Okay, so we denote the two inputs with a plus and a minus symbol, and we call them as inverting and non-inverting inputs. Minus for inverting, plus for non-inverting inputs. Okay, you can also call for simplicity plus input minus input. Okay, so this is what an op amp is. Now, what we need to know? We need to know how it works. Okay, so what is the relationship between the input and output? Okay, so input output relation. And it's very simple. So if I call this input, let me call this Vp, P for positive, voltage positive, and call this Vn, N for negative. So these are the two inputs. I am giving them name Vp and Vn, and this you call Vo, O for output. Okay, the rule is if Vp is greater than Vn, okay, then Vo is equal to some positive voltage. Okay, how much? For that I have to draw another thing. I forgot to draw the power supply. Okay, so these are power supplies because this is an electronic equipment, an IC, so it has some power supplies. Call this as V supply positive and call this as minus V supply. Okay, if Vp is greater than Vn, then the output will be equal to plus V supply. This is the rule. And else, or let me write it this way, if Vn is greater than Vp, then Vo will be equal to minus V supply. So that's the rule. I mean, that's the main thing that one should know about op amp. Okay, so it has two inputs, one output, two power supplies, among other things. So these are the main things. It has two power supplies. If these two voltages are plus V supply and minus V supply, then if Vp is greater than Vn, output is positive. If Vp is less than Vn, output is negative. So you observe the op amp compares the two inputs and tells us which one is higher, and tells us which is higher, Vp or Vn. This is so simple. Okay, so that's why we call an op amp also as an comparator. Okay, because it compares the two inputs and tells us which is higher, Vp higher or Vn higher, as simple as that. Okay, So now when you know this simple thing, let me show you a bit complicated representation of this simple fact, which is a pictorial or graphical representation of this simple fact. So what I want to do, I want to draw a graph, a picture representing input versus output. Okay, so I will draw input versus output. Okay, output is nothing but VO, but input, I am in trouble because we have two inputs, VP and VN, but I have one x-axis, one input axis. How do I put two inputs, VP and VN? I do not have a 3D graph. I do not want to make it that complicated. But what I will do, just observe that output depends only on the difference between VP and VN. Call it VP minus VN. It doesn't depend on the value of VP or VN separately. It depends only on the difference. If the difference is positive, that means VP is higher, then the output is positive. And if this difference is negative, that means VP is lower than VN, then output will be negative. Okay, so it's possible that VP is equal to 5 volt, VN is equal to 3 volt. Then this will imply VO equal to, VP is higher, so VO will be equal to V supply. Okay, example. Okay, similarly, another example you take, VP is equal to say 2 volt and VN is equal to say 1.5 volt. Then also VO will be equal to plus V supply. It doesn't depend on the actual value of VP or VN. It depends only on the difference, right? It doesn't depend on the actual value of VP or VN individually. It depends only on the difference. Therefore, why do we not put the difference as the input instead of putting VP or VN separately, right? So I will use this. Now you observe that on this side, right side, okay, on this side, VP minus VN is greater than 0. Okay, so on this side, right side, we have VP minus VN greater than 0, and on this side we have VP minus VN less than 0. This implies VP is greater than VN, and this implies VN greater than VP. And now what does the rule say? If VP is higher, output will be positive. Okay, and if so here we will have a positive output whose value will be equal to plus V supply, and it doesn't depend on the difference actually. The difference can be VP, so say here VP minus VN is 1 volt. Then also the output is plus V supply. Say here at this point the VP minus VN is 2 volt. Then also the output is same plus V supply. Here, say here this value is 4 volt. So that means VP is 4 volt more than VN. Then also the output is plus V supply. So therefore we have this a straight horizontal line. It doesn't change. Okay, and so normally, if say for example, normally we have this V supply is equal to 12 volt or maybe 15 volt. These are the normal values. Then in this case we will have minus V supply equal to minus 12 volt or minus 15 volt. then this value is actually 12 volt or 15 volt. Now the difference can be 1 volt, 2 volt, 4 volt, anything, but the output will be same as 12 volt constant. It's not going to change. Okay, but on this side, left side, Vp is less than Vn. So output now should be negative. Okay, and it will be negative and constant. No matter how large or small this difference is, no matter how more the Vn is compared to Vp, it can be more by 1 volt, it can be more by 2 volt, but the output will always be negative. So this is how it is. It's constantly negative, equal to minus V supply, and here you can put an arrow to indicate that it goes on like this, flat, horizontal. Also you can call this a saturation. Okay, it doesn't increase or decrease any further, ideally. So this is the graphical behavior. The same fact, just two-line fact, that if Vp is higher, output is positive, if Vn is higher, output is negative. This small fact can also be represented graphically, pictorially with this diagram. And this diagram we call it the static characteristic. Why static? Okay, just to say in one line, because the output in the input output relationship is true, strictly true, if the input or output is not changing with time. Then only this relationship is strictly true. But if input or output is changing with time, particularly if they are changing very fast, then the input output relationship doesn't follow this pattern or this rule. Okay, so that's why we call it static characteristic. Okay, roughly speaking. Okay, now you may ask the question, what happens if Vp is equal to Vn? That means at this point. Okay, so what happens here where Vp minus Vn is equal to 0? That means Vp is equal to Vn at this point. The answer is, at this point or close to the region of this point where Vp is very close to Vn, the output changes slowly from the negative to the positive value, like this. And at this moment I do not bother much whether this is a straight line or a curved line. At this moment I do not care. The important fact that I say is that near this region where okay, where Vp is close to Vn, output changes gradually from negative to positive. Let me just copy this diagram. Okay, so let me just zoom into this part only. Okay, here where Vp is approximately equal to Vn, then the output changes gradually from minus to plus value. This gap where the output goes from negative to positive is called the resolution of an op-amp. Okay, so this gap is called the resolution. Ideally, this gap, the resolution or the gap should be very small, or ideally 0. For an ideal op amp, we will say that this is equal to 0. So that means the pattern, the input output characteristics would be like this, almost a vertical line like this. This is the ideal characteristic. Okay. And for a practical op amp, of course, this will not be 0. And the larger the gap is, we will say the op amp is bad, worse. Smaller the gap is, we will say the op amp is better. Why? Because this is the region where the op amp is confused. What is the task of an op amp? The task of an op amp is to compare two inputs and tell which input is higher. How does it tell? By making the output either positive or negative. If Vp is positive, then it tells that, if Vp is higher, then it tells that by making output positive. But if Vn is higher, then it tells that by making output negative. But in this region where Vp is close to Vn, op amp is confused, which is higher, they are very closed. So that's why it doesn't make the output too positive, completely positive, or completely negative. It makes the output somewhat in between. Okay, it's confused, it's not very sure. So the output is not completely positive, not completely negative. So output is somewhere in between, depending on how large Vp is compared to Vn, or how large Vn is compared to Vp. So this is the region where op amp is confused. So the smaller the region is, we say the op amp is better. Okay, that's it. That's the main thing one should know about the op amp. This is the first rule that one should know about the op amp. Now the second important rule that one should know about the op amp is that, call it rule 2. Okay, so this is rule 1. This is nothing but input output relation. And rule 2 says that this is my op amp, plus minus, these are the two inputs. Now I can connect these two inputs to any voltage source, this also to any voltage source, like this way. The rule 2 says this current, call it IN, and this current, call it IP. Okay, the current that goes through the input terminal, positive input terminal, P for positive, and this current IN through the negative input terminal. The rule 2 says IP is equal to 0 for an ideal op amp, and IN is also equal to 0 for an ideal op amp. No matter how large or small these voltages are, this voltage is Vn, this voltage is Vp. No matter how large Vn and Vp is, In and Ip is going to be 0, which means no current can go into the op amp through its input terminal, either of these input terminals. Similarly, no current can come out from these input terminals. Okay, so no matter how large or small Vp and Vn are, In and Ip are equal to 0. Practically, it's not 0. This is for theoretical op amps, ideal op amps. Practically, it's not 0, but it is very small, maybe microamperes. You can neglect it. It's so small that for most of the calculations, you can neglect it. Okay, so this is rule 2. We also call this by saying that the input impedance or resistance of the op amp is equal to infinite. What is input impedance? Input impedance is nothing but the ratio of input voltage by input current, which is nothing but, now input voltage, if you are considering this terminal, negative terminal, then the input voltage is Vn divided by input current is In, or if you are considering this terminal, then this is Vp positive by Ip. In either case, the denominator is equal to 0. The denominator, this is equal to 0, this is equal to 0 or very small, and this is a finite number, numerator is a finite number, therefore this is equal to infinite. So this is the second rule about an op amp. Okay, so these are the two rules about an op amp that one should remember, and with only these two rules one can solve almost any problem involving op amp. One can analyze any op amp based circuit using only these two rules. What are these two rules? Number one, the input output characteristics shown here, which if I say verbally, output is positive if Vp is higher, output is negative if Vp is lower. Rule number one. And rule number two, no current can go into the op amp through the input terminal, no current can come out from the input terminal. That's all. Okay. So let's continue from this point onwards. Okay. Thank you.